Okay, so I can't believe what I was misunderstanding from this lesson. It was so simple. So I'm just going to show you real quick. So once you have converted this into completing the square into the take that completing the square and put it into that format, um, which this is on 100.3, where we have y equals a negative x plus 3 squared plus 1, where we know that it opens downward. We know that this is the axis of symmetry, it's the x value, the opposite sign, and where we know that this is the y value, which is the vertex, the y value for the vertex, so positive 1. Um, in order to find another point to use to graph this parabola on, you can pick any number for x and substitute that in for x to get another point. I was just confused because I just got confused when I was looking in the book. So we could now one point that will always work will be that y-intercept, so that 0 comma negative 8. But in this particular problem, they didn't use that because it graphs off of the graph that's in the book. So you notice that the lowest that it goes down is 1, 2, 3, 4, 5. It only goes down 5 places on that graph. So they picked another number to substitute in for x in order to find a y value so they could have a point. So if we did that, that's where they got that negative 1 from, is they just picked a random point. They put it into the problem. So this is going to be a positive 1. And then this is going to be plus 6 minus 8. So negative 1. Oops, not plus. Negative 6 plus 8 is negative 2. So this is a negative 3. And that's how they got y equals negative 3, is they just picked a random point, a random x value that would be low enough so that when it graphs, it would graph on the graph. So if that y is negative 3, I can show you how to graph that. So here is, let me go ahead and put out on coordinate plane up. All right, so we know that the vertex is at x, where the x is negative 3 and the y is positive 1. So I'm going to go to the left 3, 1, 2, 3, and then up 1. So that's the vertex of that parabola. And then I know another point is going to be when x is negative 1 and y is negative 3. So if I go 1 to the left and then 3 down, 2, 3, that's another point on my parabola. Well, this is the line of symmetry. So I know that 2 places over from that, because this is 2 places to the right, that the other matching point is going to be 2 places to the left. And we could do the same thing by putting another value in, like instead of that negative 1, we could put, let's say we put a negative 2 in, y equals a negative 2 squared minus 6, negative 2, negative 8. Let's see if that works. It's going to be a negative 4, positive 4, negative 4. And then this is going to be 8 times, it's going to be 6 times 2 is 12. So positive 12 minus 8 is 4. So that's a positive 12 minus 8, which is 4. So that's going to be negative 4 plus 4. So that's going to be 0. So when x is a negative 2, then y is 0. So let's see if that works. So negative 2. And no, that did not work. I did something wrong here. Let me try it again. going to use. I think I tried to rush that. So minus -2 squared minus 6 times -2 minus 8. All right. So this is +4. This is -6 times -2, which is +12 minus 8. So -4 plus 12 minus 8 is 4 is 0. So when x is -2, y 0. Oh, that is another point. It's just way up here. Sorry. I thought it would give me a point down there, but it didn't. It gave me a point this way. All right. Anyway, that is on the parabola. It's just a little bit further up on the graph. And this is the parabola. And as you can see on my graph, I've got 1, 2, 3, 4, 5, 6, 7, 8. I actually can graph the y-intercept, which is that 0, -8. So 0 and then -8 down, 1, 2, 3, 4, 5, 6, 7, 8. So that is a point on the graph. And then if I go 3 over on the left of that axis of symmetry, 1, 2, 3, that is the other point. And that is our parabola. Okay. Well, I hope that makes sense. So you would only have to substitute a random number in for x if you needed another point. You can always use the y-intercept if it graphs on your graph first. And then if it doesn't, then you can pick a point for x and find a value for y and use that x and y value to find another point on the graph. Okay, thanks, guys.